Hi guys, today's lesson is on limiting reagents, and this links nicely with reacting masses and number of moles, and it's a higher tier lesson. So you only need to look at this if you're studying the higher tier. Let's get on with the questions. What is a formula for calculating mass when given the moles and MR of a substance? So hopefully you can remember the calculation triangle by now, and that is moles equals mass divided by MR or molar mass. And if we cover up what we want, in this case the mass, we'll see that it's moles times MR. So the equation is mass equals moles times MR. The next question says define Avogadro's constant. Avogadro's constant is the number of atoms in 1 mole of a substance. Now the last question says balance this equation. To do that, put a dashed line to separate the left hand side from the right, and then start to count up the number of atoms of each element on the left and each element on the right. So we've got 1 magnesium and 1 magnesium. So far they are balanced. We've got 2 oxygens on the left, but only 1 on the right. So to make sure we have 2 on the right, we need to put a big 2 there. Now this changes our amount of oxygens, but also the number of magnesiums. We now have 2 magnesiums on the right. So to balance that on the left, we add a big 2 here. If you want to understand limiting reagents, it's best that you look at a list of ingredients. Now this says that Joe has an order for 100 cheeseburgers, but he's worried he won't be able to make that many. Look at his ingredients below and explain whether he can or cannot make them. Now the first thing to point out is that Joe's an idiot. If you can't look at his ingredients and realise that he can't make enough burgers, then we've got a problem. But let's see why he can't. So Joe has 100 buns, so he has enough buns to make the 100 cheeseburgers. He has 80 burgers. He doesn't have enough burgers to make the 100. He has enough cheeses, and he has way more lettuce than he needs. So in chemistry terms, we say that the burgers are the limiting reagent. They're the things that are stopping him making his cheeseburgers. There's also another phrase which we use in chemistry called excess, and that means a thing we have way too much of, in this case the lettuce. So here you go, just to recap. The burgers are the limiting reagent, the things we don't have enough of, and the lettuce is an excess. So if we want some definitions then, excess is the reactant that's added to make sure the reaction reaches completion. We add too much of it, so they all react. And the limiting reagent is the reactant that gets used up first in a reaction. Now in your GCSEs, you're going to be asked to work out the mass of a limiting reagent or the mass of a product based on a limiting reagent. So here's some simple steps to help you work it out. The first thing to do is write a balanced equation. Then work out the MR of the limiting reactant. Then work out the moles of the limiting reactant. Then go back to your balanced equation to see how many moles of your product you'd form. And then use the calculation triangle, which we've looked at previously, to convert the moles and then work out the mass of the product. We're going to have a look at 2 examples today, and hopefully you'll see that if you follow these steps, it's not too difficult. The first example says 3.7 grams of calcium hydroxide reacts with an excess of hydrochloric acid, forming calcium chloride and water. What mass of calcium chloride is produced? Right, so if we follow our steps, we should be able to work through this nice and easy. Write a balanced equation, that's the first thing to do. So let's look at our reagents then. So calcium hydroxide reacts with an excess of hydrochloric acid. So they're the things we start with. So calcium hydroxide reacts with hydrochloric acid, and that produces our calcium chloride and our water, H2O. Now we must make sure this is a balanced equation. So 1 calcium on the left, 1 on the right, 2 oxygens on the left, but we haven't got 2 on the right, so we're going to add a big 2 here. We've now got 2 hydrogens there and 1 here. So we've got 3 in total on the left, but we've got 4 in total on the right. So if we add another 2 here, we'll see we now have 2 and this 2 here, which is 4 in total, so that's good. Now finally the chlorines, we've got 2 chlorines on the left, 2 on the right. So we're balanced now. Now the next thing to do is work out the MR of the limiting reactant or the limiting reagent. Well, we know that because if we look at the question, we'll see that hydrochloric acid is in excess. So the other one must be the limiting reagent, which is this one here. So this is our limiting reagent. So in order to calculate the MR of this, we have to look at the periodic table, find the mass of calcium, 2 oxygens, hydrogen, and then add them all together. Now if we do this, you will get 40 plus 2 times 16, that's for the oxygens, plus 2 times 1, which is for the hydrogens. Add all that together and you'll get 74. So we've worked out the MR of our limiting reagent at 74. Now work out how many moles there are of our limiting reactant. Well, if we look at our triangle here to work out moles, it's the mass divided by MR. So we've got our mass, that's in the question, 3.7 grams. 3.7 grams divided by our MR, which is 74, and that equals 0.050. So now we've got our moles. The next step is to use the balance equation to work out how many moles of a product will form. Well, this is in a stoichiometry, which means the ratio, the molar ratio, we have 1 of these, and that produces 0.050. I want to know how much calcium chloride there is. And then if you look at the ratio between the two, it's a 1 to 1. So if we produce 0.050 moles of this, we'll produce the same amount of this as well. Just to be clear, if we was looking at this one, this is in a 2 to 1 ratio because it's got a big 2 and that hasn't got a number, which means 1. So if we had 0.05 moles of this, that'll be double the moles of this, so we'd have to half it. We'll look at some more complicated examples later, but for now all you need to know is that this is in a molar ratio of 1 to 1, so the amount of moles is exactly the same. Now the final step is to use the moles that we've just got here to calculate the mass. So this time we want the mass. A mass is moles times MR. So the final step is moles, 0.050, times the MR of the product we want, in this case calcium chloride. So the MR of calcium chloride is 40 plus 2 times 35.5 chlorines, and that works out at 111. So if we multiply this number here by 111, we should get our mass in grams, which is 5.6. And there you go. That's all there is to it. Let's have a look at another one. The next question says, what mass of aluminium oxide is produced when 135 grams of aluminium is burned in air? Now there's something very important to point out. Whenever this question mentions air, it's always talking about oxygen and it's always in excess unless told otherwise. So you need to know that as we're going through this example. Now the first thing to do is write a balanced equation. So we have aluminium and that's reacting with oxygen in the air to produce aluminium oxide. Now I'm going to balance this really quickly. If you don't know how I balance this, go back and look at the video on balancing equations where we go through this exact example. So I'm going to put a 2 here, which makes 4 aluminiums, so 4 on the left, and also 6 oxygens, so we need to put a 3 here on the left. Now we have a balanced equation. We need to work out the MR of the limiting reagent. Now the limiting reagent is the aluminium, because we said it burns in air, which is in excess. Now, very important is that aluminium is an element on the periodic table. It doesn't have a molecular mass, it has an atomic mass. So whenever I'm talking about the AR, I'm also talking here, just when I'm talking specifically about aluminium, about its AR. The AR is for individual elements, but when they're combined or in compounds, we do the MR. Okay, so the AR of aluminium is 27. So that's done. The next step, work out how many moles there are. So over here, moles equals mass divided by molar mass, or in this case the AR. So mass is, from the question, 135 grams. 135 grams of aluminium divided by 27. And how many moles does that give us? That gives us 5 moles. So we can put that up here. Now we need to use the balanced equation to work out how many moles of our product will form. So remember, like we said before, this is a molar ratio. So if I form 5 moles of this, how many moles of this will I form? Well, look at the ratio. It's of 4 to 2. So effectively, this aluminium oxide is half the amount of the aluminium, because it's a 4 to 2. 2 is half of 4. So if we form 5 moles on this side, we'll form 2.5 moles on this side. So we've worked this out. Now what we need to do is go back to our calculation triangle to work out mass of our product. Mass is moles times molar mass. So our moles is 2.5 times our molar mass of our product, which is aluminium oxide. And that will give us our answer. So let's have a look at that. 2.5 times, and the molar mass of aluminium oxide will be 2 times 27 for the aluminiums, added together to 3 times 16. So do all that, then multiply it by 2.5, and you should get 255 grams. And that's all there is to it. So I'm going to leave you with 4 questions now for you to have a go at. And make sure if you need any worked examples or need any more support with this, you put some comments below. See you later.